Today we're going to continue to learn about how we can modify hydrocarbons with functional groups. We're going to put together our knowledge of alcohols and carboxylic acids in order to form esters. Esters are really interesting because esters are the first thing we've seen that can break up the parent chain. And that's because esters are actually formed from the reaction of an alcohol and a carboxylic acid. A good example of these are fats within our bodies. Fats and lipids contain fatty acids, but they also contain an alcohol called glycerol. So they're actually able to combine those two molecules together through a type of reaction called a condensation reaction, by taking the OH from one molecule and the hydrogen on the OH of the other one and pulling it out as a water molecule. And what that does is that leaves a carbon with an unfull octet, and it leaves an oxygen with an unfull octet. You got two things in close proximity with an unfilled octet, they're going to bond themselves together. And what that does is that fuses the two parent chains together, and they're connected by what we call an oxygen bridge. So we call these condensation reactions, and we'll talk about them a little bit more at the end of the year. They're also called esterification reactions. Unlike every other organic compound we deal with in Chemistry 30, these esters have two words in their name, not just one. The first name comes from the alcohol. This will be the chain that only has a single oxygen bonded to it. That alcohol is going to change the end of its name from OL to YL. It's going to look very similar to as if it were a branch. But importantly, unlike a branch, this actually gets to be its own word. There's going to be a space between the ul and the next part of the name. The second part of the name is always named from the acid, and we change the oic acid to O8. So for example, if I used ethanol and propanoic acid to make an ester, it would be called ethanol propanoate. And I'll show you in an example what that would look like and how we can figure out what is what in these diagrams. And the acid part as well, the alcohol you can always identify because it's got one oxygen bonded to it. The acid you can identify because it's always got two oxygens bonded.